Hey everyone, I hope everyone can see me. So last class of the week, it's Friday, TGIF. So let me see what I was gonna say. I hope you can access Lumen, okay? What I did do was I set it up so that when you click on the link on Blackboard, it opens in a new window. I think someone said that when it opened in the same window, it was giving them trouble, so I set it up so it opens in a new window. I do have office hours today at 2. Again, if you can't access Lumen, contact me, please, because, Monday is when homework will be assigned. And I fixed that problem in the calendar when you're not able to see homework is defined. For some reason, I made it so that it was in my personal calendar, not in the class calendar. It was my fault. Again, I fixed it for homework 1. So homework 1 will be assigned on Monday, and it will be due the following Sunday. So you have almost a week to do it, okay? So today we're gonna keep going in chapter 1. Okay, we're gonna finish Pythagorean's theorem, and we're gonna do a little bit of circles. Should be fun stuff. All right, let me stop the camera and we'll get started. All right. I did email the notes, so, oh, here it is, okay. Here we go. All right, let me just share the, here we go. I did email the notes to everyone, so you should have it. Okay. All right. See, can everyone see this? Let's see, I think, yeah, everyone can. Okay, so we're still working in Pythagorean's theorem, which is, again, is a very important theorem about right triangles. And so here we're going to add, and remember, what we said last time was any right triangle has to satisfy Pythagorean's theorem. Okay, so if you claim to have a right triangle with these side lengths, with certain side lengths, well, that right triangle better satisfy the Pythagorean theorem. Otherwise, something is wrong. So really, we're going to approach that today. We're going to ask, can we have a right triangle where the side lengths are these 3, 6, and 10? Is it possible for that to happen? Well, remember, since we're claiming it's a right triangle, Pythagorean's theorem would have to hold here, right? In other words, that a squared plus b squared, a and b being the lengths of the legs, would have to equal c squared. C is the hypotenuse. The longest side has to be the hypotenuse in a right triangle. So here we're basically saying, can we have a Pythagorean's theorem? What is it?
I actually have a question to ask that's kind of off topic, if that's okay.
What?
So I saw in the syllabus that all of our homework assignments are on Lumen Learning,
Yeah.
but I didn't see like any link. I saw like the videos, I saw the textbook and like the chapters, but I
The
didn't.
homework isn't available yet.
Oh, okay.
Okay? I said it would be
All
on
right, thank you.
February 1st. Okay?
All right, thank you.
You're welcome. Okay, so again, so with this theorem, okay, with the right triangle, if we have a right triangle like this, Pythagorean's theorem has to hold. It must hold, okay? And again, the 10 would have to be the hypotenuse if we did have such a right triangle. The hypotenuse is always the longest side. So the other two sides would have to be legs, okay? So we're basically saying, can this happen? Well, so the right triangle would have to look something like this. I mean, you could have the 6 and 3 interchanged, but the 10 would have to be the hypotenuse if we had a right triangle with these side lengths. Okay, so Pythagorean's theorem would have to hold. Now, does it hold? Well, is 3 squared plus 6 squared equal to 10 squared? Well, is that true? Well, the answer is no, because 3 squared is 9, 6 squared is 36, and 10 squared is 100, right? Well, the sum on the left is 45, and the sum on the right and the number on the right is 100. So this equation does not hold, so we can't have such a right triangle. We can't. So we can't have such a right triangle. Again, for a right triangle like this to exist, it would have to look something like this, or maybe the 6 and 3 could be interchanged. But the longest side would have to be the hypotenuse, and Pythagorean's theorem would have to hold. And as we can see, Pythagorean's theorem does not hold. So we can't have a right triangle like this. Now, if you set up the right triangle this way, again, we can see it doesn't. We can see that Pythagorean's theorem would not hold. If you did happen to interchange the legs, as you can see, you're still going to get the same conclusion, because you would have 6 squared plus 3 squared. Here we had 3 squared plus 6 squared. And, it's the same conclusion because addition is commutative. So again, what's that? Someone's not muted. Okay, thank you. So again, right, you would still get that something is wrong, and Pythagorean's theorem does not hold. Okay, so again, it's just basically checking if you can have a right triangle with certain side lengths. You just have to see if Pythagorean's theorem holds. That's all. So that's one example. Okay. All right. And again, here I put the 6 over here and the 3 down here. I know it's not drawn to scale, but that's okay for now. If instead you interchange, you had 3 up here and 6 down here, that's fine. Either way, Pythagorean's theorem is not going to hold. All right. Okay, let me do okay, so that's one example. Let's do a related, let's do this one. Okay, so this is one I was going to have everyone try, actually. So we want to know, can we have a right triangle where this happens? So I was going to have you guys try it, but let's do it together. So, okay, so can we have a right triangle with side lengths 3, 14, and 12? Well, if we had such a right triangle, the 14 would have to be the hypotenuse. It's the longest side. Remember, the hypotenuse is always the longest side of the 3. And the other 2 sides have to be legs. So the triangle could look something like this. Now, and then you check, does Pythagorean's theorem hold? Okay, well, we have 3, right? That's a leg. 12 is a leg. And as I said, 14 would have to be the hypotenuse. So we would have 3 squared plus 12 squared would have to equal to 14 squared. 3 squared plus 12 squared would have to equal to 14 squared. And now, does that happen? Well, 3 squared we know is 9. 12 squared is 144. 14 squared is 196. Again, you can get these numbers just by using your calculator. When you have this little 2 up here, it's an exponent. That just means you multiply the number with itself. That's all it means. You're multiplying the number with itself. So this is really 12 times 12, which is 144. 3 squared is 3 times 3, which is 9. 14 squared is 196. Okay, so is this equation true? Well, we have 9 plus 144. That's 153. Here we have 196, but this is not true. 153 is not the same as 196. So because of that, Pythagorean's theorem does not hold here. Well, that does, okay, so since that doesn't hold here, we can have a right triangle like this. And again, if you decide to interchange the 3 and the 12, you don't have to do this extra step, but if you happen to write the triangle this way, you're going to get the same conclusion. you're going to get the same exact. I thought someone had a question. I'm sorry. You're going to get the same exact conclusion. You would get 12 squared plus 3 squared equals 14 squared. But again, you're adding, right? Addition is commutative. So that's the same as what we had in the previous slide. And so you get 9 plus 144. The equation would be this equals 196, which again is not true. So again, Pythagorean's theorem does not hold. So because of that, the equation is not true. Okay. Oh, sorry. I see. I think I accidentally stopped sharing it. I'm sorry. Not sure how that happened. Let me fix that. Must have clicked something. Ah, boy. Here. Can you see it? Can everyone see it now? There we go. Okay. Sorry about that. Okay. Good. Wait. Someone say something else. Okay. Good. Sorry about that. Okay. So now, again, that's what we were saying. So from this example, again, so here. So we finished. So we had this one, but again, I think the slide wasn't sharing. So let me just go through it again. The 3 and the 12. Okay. Here. The 3 and the 12. If you happen to, write it this way on this first slide, we had it like this. If you happen to write it this way instead, it really doesn't matter because by Pythagorean's theorem, you would be adding the legs squared together, and addition is commutative. So basically, you can't get a right triangle like this, is what we're saying.